Hello, my young minds. How are you? I hope you are doing well. And my name is A. Prithviraj. I have completed my MSc Zoology, MA English Literature, and B.Ed. This is the 15th year of my experience in the teaching field. And today we are here to discuss about few questions regarding the breathing and exchange of gases. Breathing and exchange of gases. In that, here given the question about respiratory volumes and capacities. Respiratory volumes and capacity. The respiratory volumes and capacities begins with tidal volume. Tidal volume. What is the tidal volume? The amount of air you are inhaling and exhaling out is called as tidal volume. That is approximately what happened? 500 ml. 100 ml. So now what happened here? The total, if you are breathing for 12 to 16 times per minute, then it is nothing but 6,000 to 8,000 ml of air you are breathing in a minute. That indicates your total lung capacities. Lung capacities. Let us do how much air is exhaled out, inhaled it, and how we are going to tally this amount. So based on that, we are going to solve this problem. So how this will get the solution? Let us see here. Isn't it? So let us see the first one here given about expiratory capacity. Expiratory capacity is nothing but EC. Expiratory capacity is indicated in such a way that the amount of tidal volume plus expiratory reserve volume. Expiratory reserve volume. What is expiratory reserve volume? The forcible expiration after the normal expiration. The forcible expiration indicates the expiratory reserve volume. So now indicate here. What is happening? You can see the options. Expiratory reserve volume, tidal volume. No. It is tidal volume and expiratory reserve volume. Now it is 2. So the option 2 is correct here. A tallies with option 2. Now rest of the things you see here. Second option is showing A is 3. That means it is indicating tidal volume plus expiratory reserve volume. So it is wrong. Now third one is indicating same as 2. Then fourth one is indicating A. Expiratory reserve volume plus tidal volume plus expiratory reserve volume. So this option is wrong. So now what is happening here? These two we can eliminate. Now you can see as first option and third options are A is indicating 2 only. Then let us see go with the B option. What is the B? Functional residual capacity. Functional residual capacity. What is functional residual capacity? Is the amount of air present within the lungs. Isn't it? That means whatever breathing outside, complete air is not eliminated out of the lungs. If it is taking place, oxygen is not available to the blood or into the tissues or to the body, isn't it? So gap will be taking place. So it is not taking place. Compulsory, the residual volume will be there. That is 1100 to 1200 ml will be constant in each line. So that's why it is here residual volume. Now functional residual capacity. Functional residual capacity indicates that as what is it indicating? Expiratory reserve volume plus residual volume. Expiratory reserve volume plus, and that is forcible expiration. After that forcible expiration, how much of amount of air is present in the lungs plus remaining whatever the amount of residuing amount of air is present in the lungs, that will become your residual volume. So where is indicating? Yeah, fourth is indicating that one. So option B is indicating fourth. Now you see here in the option 2, B is indicating 2. So now this is wrong. Then option 3, B is indicating 1. So it is wrong. Now option 4, B is indicating 3. Now this is wrong. So already we got the answer here, right? Let us see. Moreover, some may be having the doubts. Let us see that one also. Now that is the vital capacity. Third one is indicating, C is indicating vital capacity. What is vital capacity? What is vital capacity? The amount of air constant in the lungs, okay, that shows the vital capacity. That indicates the respiratory reserve volume plus tidal volume plus inspiratory reserve volume. Expiratory reserve volume plus tidal volume plus inspiratory reserve volume. Now you see here, inspiratory reserve volume indicates that forcible inspiration. After the tidal volume, forcible inspiration, how much you are able to take inside. That indicating the nearly 1200 ml. Sorry, 3000 ml. This is 1200 ml. 2500 to 3000 ml. Isn't it? It is 1100 ml. And this is 500 ml. Now total will be the vital capacity. Vital capacity. Now find out the option where. Yeah, first one is indicating aspirated reserve volume plus tidal volume plus inspirated reserve volume. Now the C is indicating 1. So indicating is, so where is the option? In the A it is showing us. Now, but whereas here C4, here also C4, here it is C3, C2. So now it is indicating this is wrong, this is wrong, this is wrong. Now let us see the fourth one. What is the inspiratory capacity? Inspiratory capacity. What is inspiratory capacity? Inspiratory capacity indicates a tidal volume plus inspiratory reserve volume. The normal tidal volume is, already I told you, 500 ml plus inspiratory reserve volume how much? Nearly 2500 to 3000 ml. Now this will be becoming an inspiratory reserve volume. Now find out where is the inspiratory reserve volume in this. Yes, it is indicating total tidal volume plus inspiratory reserve volume. That is nothing but 3 option. Now this is a 3 option because here already D is indicating 3 and the third option, but here it is not indicating, here it is not indicating. So here confusion is that A option and D option, but the remaining is wrong. So here when you come to know the first 2 options, automatically you come to know the other 2 options also. But here you can see, for your doubt clarification, I have given you all the 4 options. So now as it is indicating 3 and 2, this is wrong. Now this is wrong and this is wrong. And the option A is, or the option 1 is correct. So the correct answer for this option question is option A, isn't it? So we can go with the elimination process. If you know the correct definitions of the respiratory volumes and capacities, if you don't know, then what you have to do? You have to tally each and every one, and you can mention there like that it is 2, isn't it? It is 4, it is 1, and it is 3, and then you have to indicate here. Then that will be also one of the easiest form, but it will be taking the time taking process. When you go with the elimination process, that will be easy. So because here when you are indicating the A, automatically it is showing. Suppose if the same option is there in the another option here, then we will go with the B. Then we go into the B. If the B is also any other option is indicating, then we will go to the C. Otherwise, the option will be yes, isn't it? So this is the option. So here what is happening here? It indicates that different capacities based on inspiration and expiration, that shows the total lung capacity. Total lung capacity. Average we will be breathing for 12 to 16 times per minute. Nothing but 6000 to 8000 ml of air will be taking within the minute, isn't it? So that is the capacity of our lungs. Now let us see the second question. What is the second question? Let us see. Now let us see the second question. What is that question indicating? That which of the following factors are favorable for the formation of oxyhemoglobin in alveoli? Oxyhemoglobin in alveoli. That means here what is happening? Alveoli. Whatever the oxyhemoglobin is taken, which is in alveoli. Alveoli is present in lungs. How the oxyhemoglobin is taking place? Hemoglobin acts as a buffering, right? Yes. See, hemoglobin consisting of ferrum, that is about iron. How many molecules? 4 molecules. So each molecule has 4 iron molecules, right? Each one has the binding capacity to bind with oxygen. So 4 oxygen molecules will be binded with each hemoglobin molecule, right? Based on the iron compound present in it. So based on that, let us see here how the oxyhemoglobin dissociation is taking. Association and dissociation will be taking place. Further, here what is happening? The question is asked that which of the following factors are favorable? Which are favorable for the formation of oxyhemoglobin. That means oxygen should bind with the hemoglobin. For that, what are the favorable conditions? This is the question. What are the favorable conditions? This is the question. Let us see. To understand that, let us go with the graphical representation, okay, which shows the oxygen dissociation curve, isn't it? For example, you see here via x-axis it indicates that partial oxygen. What is the partial oxygen? Yes, it is the amount of the gas showing its higher affinity when compared to all other gas. Individual gas showing is the higher affinity to bind with the hemoglobin when compared to the other gases. That's called its partial oxygen capacity, isn't it? In the same way, carbon dioxide also. Now you see, to bind with the hemoglobin, what is required? pH is less, high, isn't it? pH is high. That means H plus concentration should be less. Okay, pH is high is required. And second one, carbon dioxide is low. Carbon dioxide, partial carbon dioxide should be low, as well as temperature should be low. Temperature should be low. Now, this is, here what happened? High partial pressure of oxygen is necessary. Partial pressure is necessary. High partial pressure of oxygen, lower concentration of H plus ions, that is the pH level is high, and lower carbon dioxide and lower temperature is a favorable condition to bind the oxygen with the hemoglobin. To bind the oxygen with the hemoglobin, right? Yes. Now, because of that, what happened? The curve will be moving towards its left side, isn't it? This will be taking place in alveoli. That is in lungs. This favorable condition is present in the lungs. Whereas, when you come to the tissues, pH is low. That means H plus ion concentration is high, isn't it? And carbon dioxide is high, as well as temperature also high. So here what happened? Dissociation. Dissociation. That means the binding of oxygen with the hemoglobin will be decreased. It is association, it is dissociation. So because of that, what happened here? This will be moving towards the right side. But here what happened? The question is asking that oxyhemoglobin formation, what type of conditions are favorable? Then what you have to do here is, the temperature should be low, carbon dioxide should be low, the pH is high, nothing but H plus concentration should be less. Now you see option here. What is required? Partial pressure of oxygen should be high and H plus ion concentration should be less. Now find out where it is. Yes, the higher PO2 and the lesser concentration of H plus ions are favorable for binding of oxygen with hemoglobin. That forms oxyhemoglobin. Oxyhemoglobin. So the right option is option 2. The right option is option 2. And this, what are the graphical representation what we discussed here? Yes, increasing in partial pressure of oxygen, high partial pressure of oxygen, as well as lower concentration of H plus ions and lower concentration of carbon dioxide and temperature. Okay, increases the affinity of oxygen to bind with the hemoglobin. Lower here, you can see low pH, that means high concentration of H plus ions and high concentration of carbon dioxide and high temperature will result in the dissociation, that it gets oxygen dissociation curve, and this is also called as Bohr's effect. What is it called? Bohr's effect. So this is the right answer for this. That means the option is indicating the high PO2 and less concentration H plus ions. Concentration is favorable to bind the oxygen with hemoglobin to form oxyhemoglobin. Oxyhemoglobin. So this is the right answer. I hope you understand well, and I'm Prithvi Aljalaf. By that time we can complete this topic. Let us see the next questions in the next session. Okay, by that time I'm signing out. Thank you.